Question 1. The probability distribution table for a discrete random variable x is shown. What is the value of p x equals 3? The question is asking for the probability that the random variable x is equal to 3. And because it's asking for a probability, the value must lie between 0 and 1. So options C and D are both incorrect. Now the sum of the probabilities must equal 1 or 100%. So the value that's missing here must be such that all three values added together must equal 1, which means 0.4 belongs in this space. So the probability that x equals 3 is 0.4, therefore the correct answer is option B. Question 2. Which graph could represent y equals 4 to the power of x? Consider the form of the equation. We have the variable y is equal to a number to the power of the variable x. This means there is an exponential relationship between the variable y and the variable x. Looking at the base, we have a base of 4, and it is greater than 1. That means as we move from left to right on the graph is getting steeper and steeper. And out of the four options, the only option that shows this particular property is option A. Now for completeness, if we consider the other options, looking at option B, we have y equals a to the power of x. It is a type of exponential relationship. However, the base a is a value between 0 and 1. Looking at option C, this is a straight line graph, and it's of the form y equals mx plus c, where m, the gradient, is less than 0 or negative. And looking at option D, this is of the form y equals mx plus c, where m, or the gradient m, is greater than 0 or positive. Question 3. What is the domain of the function y equals the square root of 6 minus x squared? The domain of a function refers to the real values of x that a function permits as valid inputs. In this case, we have the quadratic function 6 minus x squared inside the square root function. So think of it this way. The output of this quadratic function becomes the input of the square root function. And the input of the square root function has to be a value that's greater than or equal to 0. In other words, 6 minus x squared has to be greater than or equal to 0. Rearranging this inequality, by moving the negative x squared over to the other side, we have 6 is greater than or equal to x squared, which implies that x squared is less than or equal to 6. Now we can express this inequality as a three-way inequality. This means that x is less than or equal to the square root of 6 and greater than or equal to negative square root of 6. Therefore, the correct answer in interval notation is option D. Notice the square brackets here, which mean that the endpoints are included in the domain. Question 4. Which of the following best represents the graph of y equals negative 5x times x minus 2 in brackets times 3 minus x in brackets? This is the equation of a polynomial in factor form. And because it's in factor form, we can easily work out the x-intercepts of this graph. And we do that by solving negative 5x equals 0, and we get x equals 0 as one of the x-intercepts. Solving x minus 2 equals 0, we get x equals 2 as the second x-intercept, and solving 3 minus x equals 0, we get x equals 3 as the third x-intercept. So options B and D will be incorrect because one of the x-intercepts is negative 3. So this point here and this point here for option D. So the only viable options are options A and C. and they both have x-intercepts at the origin, at x equals 2, and at x equals 3. The question though is the direction of the graph. As x gets larger, does the y value get larger or smaller? Now, in option A, we can see here that as x gets larger, the y values get smaller. And with option C, as the x values get larger, the y values get larger. In other words, as x approaches infinity, does y approach infinity or negative infinity? And now one way we can test that is to substitute another point. So for example, let's go beyond the x-intercept at x equals 3 and let's test x equals 4 and let's see what the y value is. So substituting 4 for x into this equation and then evaluating it to get the value of y, we get y equals 40, which means that the correct answer is option C. Now I'm going to present another way of looking at this using algebra. We have y equals negative 5x times x minus 2 times 3 minus x. Now look at the 3 minus x here. If we factorize out negative 1, we get negative 1 times x minus 3. Notice that the 3 and the negative x have switched places. So the x becomes positive and the 3 becomes negative. So we get y equals negative 5x times x minus 2 times negative 1 times x minus 3 rather than 3 minus x. Now negative 5x times negative 1, since multiplication is commutative, we get positive 5x. So y is equal to 5x times x minus 2 times x minus 3. And we get x-intercepts at x equals 0, 2, and 3, like before. And we can see that as x approaches infinity, y approaches infinity, and as x approaches negative infinity, y approaches negative infinity as well. Which means the correct answer, once again, is option C. Question 5. What is the integral of 1 over the square root of x plus 5 dx? Start by expressing the integrand in index form. So the integral of 1 over the square root of x plus 5 dx can be written as the integral of x plus 5 in brackets to the power of negative 1 over 2 dx. Performing the integration, noting that what's in the brackets here is a linear expression, we get x plus 5 in brackets to the power of positive 1 over 2. In other words, we add 1 to the index, but then we divide by the new index, but we also divide by the derivative of what's inside the brackets because it's in the form ax plus b. And since the coefficient of x is 1, the derivative of x plus 5 is just 1. So we're dividing by 1, which in this instance has no effect. Now, dividing by 1 over 2 is equivalent to multiplying by 2, and x plus 5 in brackets to the power of 1 over 2 is the same as saying the square root of x plus 5. So putting that all together, we get 2 times the square root of x plus 5 plus the constant c. Therefore, the correct answer is option B. Question 6. The graph of y equals f of x is shown. Which of the following is the graph of y equals negative f of negative x? Negative f of negative x means all the points that make up this graph have been reflected in the y-axis and also in the x-axis. Now take note of a particular point, and I'm looking at the point of intersection of the two asymptotes. Now the point of intersection is at x equals negative 2, y equals 1. Now negative f of negative x means the point of intersection has moved from here to here. In other words, the new point of intersection of the asymptotes will be at x equals positive 2, y equals negative 1. So there's y equals negative 1 and x equals positive 2. So looking at all four options, the only option that shows that new point of intersection where it should be is option C. Here's the point of intersection of the two asymptotes at x equals 2, y equals negative 1. Question 7. A 10-sided die has faces numbered 1 to 10. The die is constructed so that the probability of obtaining the number 1 is greater than the probability of obtaining any of the other numbers. The numbers 2 to 10 are equally likely to occur. When the die is rolled 153 times, a 1 is obtained 72 times. By using the relative frequency of rolling a 1, which of the following is the best estimate for the probability of rolling a 10? The experimental probability of rolling a 1 based on the result of this particular experiment is 72 over 153, which simplifies to 8 over 17. And we get that from this line here. When the die is rolled 153 times, a 1 is obtained 72 times. So it's almost 50% of the time. Let's consider the probability of not rolling a 1. In other words, rolling a 2, 3, 4, 5, 6, 7, 8, 9, or 10. By the law of complements, the probability of not rolling a 1 is 1 minus the probability of rolling a 1. So 1 minus 8 over 17 is equal to 9 over 17. Now going back to the question, the die is constructed so that the probability of obtaining the number 1 is greater than the probability of obtaining any of the other numbers, and the numbers 2 to 10 are equally likely to occur. And the question is, use the result of this experiment to estimate the probability of rolling a 10, which is one of those other 9 outcomes. So going back to this line here, the probability of not rolling a 1 is 9 over 17, but we want one of those outcomes that's not a 1, which is 10. So the probability of rolling a 10, which is equal to the probability of rolling a 9, an 8, a 7, and so on, is 9 over 17, because that's the sum of the probabilities of all those outcomes other than 1, dividing that by 9, and we get 1 over 17. Therefore, the correct answer is option A. Question 8. The minimum daily temperature in degrees of a town each year follows a normal distribution with its mean equal to its standard deviation. The minimum daily temperature was recorded over 1 year. What percentage of the recorded minimum daily temperatures was above 0 degrees? There are two important things to note in this question. Now, the first one is that the minimum daily temperatures follow a normal distribution. So that's a stereotypical bell curve, which means we may have to use the empirical rule to work out percentages of scores between any particular 2 points, which may mean we need to work out z-scores. So I'm sort of thinking ahead here as to what we might need to use later on. Now, the next thing to note is that the mean temperature is not stated. We don't know what it is. All we do know is that the mean is equal to the standard deviation. Now, because the scores, which represent temperatures, follow a normal distribution, we know that the standard deviation can't be 0, nor can it be negative. It has to be a positive number. It doesn't have to be an integer or a whole number, but it must be positive. And the question is asking for what percentage of the recorded minimum daily temperatures was above 0 degrees. So I'm thinking here that we need to calculate a z-score at some point. But we need a value for the mean, mu, and the standard deviation, sigma. So that's mu and sigma. So I'm going to let mu equal sigma equal 3. Now 3 is just a random positive number. It doesn't matter what you choose here as long as it's positive. If we wanted to make it easy on ourselves, we could have just chosen 1. But I've just chosen 3 just to show you how this works. The next thing is we need to work out a z-score for 0 degrees Celsius using the z-score formula. And we get z equals 0 minus 3, so that's 0 degrees minus the mean, which we chose up here, which is 3 degrees, in brackets, divided by the standard deviation 3, since mu is equal to sigma, so mean is equal to standard deviation, which equals 3, and we get negative 1. Now, it doesn't matter what value we choose here. we're always going to get a z-score of -1 using this formula and using 0 here. So we want the percentage of scores that lie above z equals -1. Now, using the empirical rule, we know that the percentage of scores between z equals -1 and z equals 1 is 68%. So between z equals -1 and z equals 0, we have 34, or roughly 34% of scores. Now, above z equals 0, that whole half of the bell curve or the normal distribution, we have 50% of the scores. So 34%, so that's from z equals -1 to z equals 0, plus 50%, which is all scores above z equals 0, gives us 84%. Therefore, the correct answer is option D. Question 9. The diagram shows the graph of y equals f dash of x. Given that f of 1 equals 6, which interval includes the best estimate for f of 1.1? Recall that f dash of x represents the first derivative of f of x, which gives us the rate of change of f of x at any given point. Now, the rate of change tells us if f of x is getting larger, increasing, getting smaller, decreasing, or no change at all. Let's consider the point where x equals 1. Now, it's given in the question that f of 1 is equal to 6. That's the value of the function itself. And I've stated that here. And from the graph, f dash of 1 is equal to 2. So there's x equals 1, project across, we get 2 here. And 2 is a positive number, which means f of x is increasing, in other words, getting larger, at x equals 1. Now let's go slightly beyond x equals 1 to x equals 1.1. So slightly to the right of 1 here. So that's around there. And the rate of change is still around 2, slightly less than 2 though. So I've stated that here that f dash of 1.1 is around 2. Now, because it represents a rate of change, it's the rate of change of y with respect to x. In other words, what is f of x doing when x changes? Now, because it's around 2, that is f dash of 1.1 is around 2, x has increased by 0.1. Remember, we started at f of 1, and now we're considering f of 1.1. X has increased by 0.1, and taking into account this rate of change, this implies that f of x has increased by around 0.2, so double 0.1. That means f of 1.1 should be greater than or equal to 6.0, but less than or equal to 6.2, which means the correct answer is option B. Question 10. The graph of y equals f of x with all its stationary points is shown. How many stationary points does the graph of y equals f of e to the power of x have? Y equals f of e to the power of x is a composite function or a function of a function. Think of it this way. X is being input to e to the power of x, which then gives us an output, and the output of e to the power of x is then being input into the function f to give us f of e to the power of x. Now, looking at the graph of y equals f of x, we can see that there are 3 stationary points. One here when x is negative, and one here and here when x is positive. Let's look at the behavior of e to the power of x. Now, y equals e to the power of x is monotonic increasing over all real values of x. And e to the power of x is positive for all real values of x as well. So in other words, regardless of the value of x that we input into e to the power of x, the range of e to the power of x are all positive values. Looking at this diagram here, we input x into e to the power of x and we get only positive values, which are input into the function f to give us f of e to the power of x. So this has the effect of restricting the input to the function f to only positive values. In other words, we restrict the graph to quadrants 1 and 4 only. So it's as if we've ignored quadrants 2 and 3. So we're only looking here and here. So we only have two stationary points when the input to function f is positive. Therefore, the correct answer is option C. Question 11. The graph of a quadratic function represented by the equation h equals t squared minus 8t plus 12 is shown. Part A. Find the values of t and h at the turning point of the graph. The horizontal coordinate of the turning point or vertex of the graph of a quadratic function lies halfway or midway between the two horizontal intercepts. In this case, the horizontal coordinate is represented by the variable t. So to find the horizontal coordinate or the t coordinate of this particular turning point, we find the average of 2 and 6. And we do that by adding them together and then dividing that by 2. So t is equal to, open bracket, 2 plus 6, close bracket. Now 2 plus 6 is equal to 8. We divide that by 2 and that equals 4. Now we need to find the value of h that corresponds to t equals 4. And we need to go back to the original equation. H is equal to t squared minus 8t plus 12. And we want the value of h when t is equal to 4. So by substitution, when t equals 4, h is equal to 4 squared minus 8 times 4 plus 12, and that equals negative 4. Therefore, t equals 4 and h equals negative 4 at the turning point. If the quadratic function is in the form y equals ax squared plus bx plus c, then the vertex or turning point of the parabola with coordinates x, y will have the x coordinate given by negative b over 2a, where a is the coefficient of x squared and b is the coefficient of x. Now replace x with t and y with h. The b term will be 8 and the a term will be 1. So t is equal to negative 8 divided by 2 times 1. So that's our negative b over 2a. And that evaluates to 4. So to find h, we substitute t equals 4 into the equation, h equals t squared minus 8t plus 12. So h is equal to 4 squared minus 8 times 4 plus 12, which gives us negative 4. Therefore, t equals 4 and h equals negative 4 at the turning point. At the vertex or the turning point, the gradient is 0, which means the value of the first derivative, h dash, is 0. So if we find h dash and then solve this equation for t, we can find the value of t at the turning point. So solving h dash equals 0, so differentiating t squared minus 8t plus 12 with respect to t, we get 2t minus 8. And then we make that equal to 0. Solving this equation for t, we get t equals 4. Then substituting t equals 4 into the equation here to find the value of h, we get h of 4 is equal to negative 4. Therefore, t equals 4 and h equals negative 4 at the turning point. Part B. The graph shows h equals 12 when t equals 0. What is the other value of t for which h equals 12? The graph of a quadratic function is symmetrical about the horizontal coordinate of the turning point. In this case, the horizontal coordinate is represented by the variable t, and we found in part A that the value of t at the turning point is t equals 4. So this particular graph is symmetrical about t equals 4. So starting at t equals 4, if we move to the left-hand side 2 units or to the right-hand side 2 units, in other words, 4 minus 2 or 4 plus 2, we land at t equals 2 or t equals 6, and the value of h, which represents the height of that point above or below the horizontal axis, is the same. Now at t equals 2 and at t equals 6, h is equal to 0. The height of that point is 0, which means it lies on the horizontal axis directly. Starting at t equals 2, if we move another 2 units to the left, t is equal to 0, so 2 minus 2 gives us 0, but the value of h is equal to 12. So this particular point here is 12 units above the horizontal axis. So going the other way, from t equals 6, moving to the right another 2 units, so 6 plus 2 gives us 8, or t equals 8, the value of h here is identical to this value here. It's at the same height, so h is equal to 12. So to sum up, the graph is symmetrical about t equals 4. Therefore, the other value of t, where h is equal to 12, is t equals 8. We can solve the quadratic equation t squared minus 8t plus 12 equals 12 to find the other value of t for which h equals 12. Now we know that h equals 12 when t is equal to 0. So the other value of t implies that there is a distinct or different value of t for which h equals 0. And we can see this from the graph by inspection. So solving this equation for t, we subtract 12 from both sides of the equation. We get t squared minus 8t is equal to 0. Factorising the left-hand side, we get t times t minus 8 in brackets equals 0. And by the null factor theorem, we get t equals 0 or t equals 8 as the two solutions. But we know that t equals 0 is one of the solutions already. We just need the other solution. So the other value of t, for which h equals 12, is t equals 8. Question 12. Find the equation of the tangent to y equals 5x cubed minus 2 over x squared minus 9 at the point 1, negative 6. The tangent to a curve is a straight line, and to find the equation of a straight line, we need the gradient or the slope of the line, and we need a point that the line passes through. Now it's given that the tangent passes through the point 1, negative 6, which is a point on this curve here. Now we need the gradient or the slope of the tangent. Now in order to do that, we need to differentiate y with respect to x, and then substitute in the value of 1 for x, and that gives us the value of the gradient of the tangent. Now, in order to differentiate this function, we need to express it using negative indices where appropriate. And in particular, this term here, 2 over x squared, is 2 times x to the power of negative 2. When it's in that form, it's easier to differentiate. So taking this equation here and representing this term here, 2 over x squared, using negative indices, we get y equals 5x cubed minus 2 times x to the power of negative 2 minus 9. Differentiating y with respect to x, we get y dash is equal to 15x squared plus 4 times x to the power of negative 3. Now when x is equal to 1, the gradient y dash is equal to 15 times 1 squared plus 4 times 1 to the power of negative 3, which equals 19. And this is equivalent to our m. Now m represents the gradient of a line when we're dealing with equations in the form y equals mx plus c. And ultimately, our solution will be in that form. Now, in order to find the equation of the tangent, we use the point gradient formula. Now that we have our gradient and we have a point. So using this gradient here, 19, and using the point gradient formula, that's y minus y1 is equal to m times x minus x1 in brackets. Now our x1 is 1, our y1 is negative 6, and our m is 19. So y minus negative 6 is equal to 19 times x minus 1 in brackets. Now minus minus here turns into a plus, and expanding the brackets there, we get y plus 6 is equal to 19x minus 19. And then subtracting 6 from both sides of the equation to isolate y, we get y is equal to 19x minus 25. Question 13. The numbers 75, p, q, and 2025 form a geometric sequence. Find the values of p and q. Since the numbers form a geometric sequence, the ratio between any two consecutive terms is identical or common. So if we let r equal the common ratio, then 75 times r gives us p, p times r gives us q, and q times r gives us 2025. Put another way, 75 times r times r times r gives us 2025. And we can shorten that further by saying 2025 is equal to 75 times r cubed. And we need to solve for r. So rearranging this equation to isolate r cubed is equal to 2025 divided by 75, which gives us 27. And then taking the cube root of both sides, we get r is equal to 3. So 75 times 3 gives us p, p times 3 gives us q, and q times 3 gives us 2025. And we can state that here. P is equal to 75 times 3, which equals 225. Q is equal to P times 3, so 225 times 3, which equals 675. So summarizing that result, we got P is equal to 225 and Q is equal to 675. Question 14. In a research study, participants were asked to record the number of minutes they spent watching television and the number of minutes they spent exercising each day over a period of 3 months. The averages for each participant were recorded and graphed. Part A. Describe the bivariate dataset in terms of its form and direction. In terms of form, this bivariate dataset could either be linear or non-linear. Now, linear means a straight line relationship, and looking at the scatter plot, we can see that the general trend follows a straight line. So the form is linear. Now, in terms of direction, as the x values are getting larger, the question is, are the y values getting larger, smaller, or neither? But we can see that as the x values get larger, the general position or the vertical position of the points gets smaller or gets closer to the x-axis. So if we were to visualize a straight line, we can see that the straight line will have a negative gradient. So the direction is negative, and I've stated the answers here. So the form is linear or straight line, and direction is negative. Y gets smaller as x gets larger. The equation of the least squares regression line for this dataset is y equals 64.3 minus 0.7x. Part B. Interpret the values of the slope and y-intercept of the regression line in the context of this dataset. To help make the question easier to answer, we can express the equation of the least squares regression line in the form y equals mx plus c in that order. So at the moment, it's in the form y equals c plus mx. Now, the m happens to be negative, which is why it's negative 0.7x. So writing it in the form y equals mx plus c, where m is the gradient and c is the y-intercept, we get y is equal to negative 0.7x plus 64.3. So the gradient or slope of this least squares regression line is negative 0.7, and the y-intercept, which represents the point where the line crosses the y-axis, so that's where x is equal to 0, is 64.3. Now we saw in part A that the direction of the bivariate dataset is negative. And this corresponds to our negative gradient here of negative 0.7. So interpreting the gradient or the slope of negative 0.7, what this means is for every 1 minute increase in watching television, the time spent exercising is reduced by 0.7 minutes. And we saw earlier on in part A that as the x values get larger, the y values get smaller. So as the x values get larger by 1 minute, the y values get smaller by 0.7 minutes. Interpreting the y-intercept, now the y-intercept is a point that occurs when x is equal to 0. Now x represents the amount of time watching television. So when x is equal to 0, that means someone is not watching any TV at all. So someone who does not watch any television is expected to spend 64.3 minutes exercising. Part C. Joe spends an average of 42 minutes per day watching television. Use the equation of the regression line to determine how many minutes on average Joe is expected to exercise each day. Let x equal 42 and substitute that value for x in the equation of the least squares regression line, which is y equals 64.3 minus 0.7 times x. So y is equal to 64.3 minus 0.7 times 42, which equals 34.9. Therefore, Joe is expected to exercise 34.9 minutes each day. Part D. Explain why it is not appropriate to extrapolate the regression line to predict the average number of minutes of exercise per day for someone who watches an average of 2 hours of television per day. 2 hours of watching television is equal to 120 minutes of watching television. Now going back to the scatter plot, the x-axis represents the amount of time watching television. And we can see that the values are from 0 to 60. There are no points on the scatter plot which correspond to values of x greater than 60. So it's outside the range of data on this scatter plot. And I've written that here. So it's outside the range of data on the scatter plot, hence extrapolation will be unreliable. Also, if we were to let x equal 120 and substituting x equals 120 into the least squares regression line equation, we get y is equal to 64.3 minus 0.7 times 120, which is equal to negative 19.7 minutes of exercising, which is clearly invalid. Question 15. A sound wave can be modelled using a function P of t equals k times sine of at, where P is the air pressure in pascals and t is time in milliseconds, ms, and k and a are constants. Part A. Write the equation for a sound wave P1 of t that has an amplitude of 2 pascals and a period of 5 milliseconds. The k in front of the sine at represents the amplitude of the function, and we're told that the amplitude is 2 pascals, so k is equal to 2. Now to work out the a, which is the coefficient of the variable t. And we use the formula period is equal to 2 pi divided by a. Now we know what the period is. The period is 5 milliseconds. So period 5 is equal to 2 pi divided by a. Rearranging this equation to make a the subject, we get a is equal to 2 pi divided by 5, which can be written as 2 pi over 5. Therefore, P1 of t is equal to 2 times sine of 2 pi over 5 times t. Part B. The graph of P1 of t from Part A is shown. On the diagram, sketch the graph of P2 of t equals 4 times sine of pi over 10 times t for t greater than or equal to 0 and less than or equal to 10. By inspection, the amplitude of the P2 of t function is 4. Now we need to work out the period of the function, which is the time it takes for the function to complete one full cycle. And we use the equation capital T, which is the period, is equal to 2 pi divided by the coefficient of the time variable t, which in this case is pi over 10. So 2 pi divided by pi over 10 gives us a value for capital T of 20, which corresponds to a period of 20 milliseconds in this case. So drawing the curve, we know it must pass through this point here, 5, 4, because the amplitude is 4 and it occurs at time t equals 5 milliseconds. Now it starts at the origin and the curve lands here at t equals 10 seconds on the t-axis. Part C. Hence, find the values of t where t is greater than 0 and less than 10, for which functions P1 of t and P2 of t are both decreasing. By inspection of the graphs of P1 of t and P2 of t, we can see that P1 of t is decreasing between this point here and this point here, and also between this point here and this point here. Now looking at P2 of t, it's decreasing between this point here and this point here. So clearly the values of t where both P2 of t and P1 of t are decreasing is between this point here and this point here. Therefore, P1 of t and P2 of t are both decreasing for t greater than 6.25 and less than 8.75 milliseconds. Question 16. Consider the function f of x equals x squared over e to the power of x. Part A. Find the stationary points of the function and determine their nature. To find stationary points, we need to find the first derivative of f of x, so that's f dash of x. And because f of x is a fraction where both the numerator and the denominator are themselves both functions of the variable x, we use the quotient rule to find the first derivative f dash of x. So recall the quotient rule, f dash of x is equal to u dash v minus uv dash over v squared, where in this case, u is x squared, u dash would be 2x, v is e to the power of x, and v dash is the derivative of e to the power of x, which is also e to the power of x. So putting that all together, we get f dash of x is equal to 2x times e to the power of x minus x squared times e to the power of x all over e to the power of 2x. Now note that e to the power of x in brackets squared using the power to a power rule is e to the power of 2x, which is why it appears in the denominator like so. Now in the numerator, we can factorize out x from this term and this term. We can also factorize out e to the power of x from both of those terms as well. So we can write the first derivative as f dash of x is equal to x times e to the power of x times 2 minus x in brackets over e to the power of 2x. Now we could cancel e to the power of x here with e to the power of 2x here, so we have e to the power of x in the denominator. But for simplicity, I'm just going to keep it this way because I don't need the denominator, in fact. Especially when we're solving f dash of x is equal to 0. A fraction can only equal 0 if the numerator equals 0. So it has nothing to do with the denominator at this stage. So we want to solve for x the equation f dash of x equals 0, and we do that by making the numerator of this fraction here equal to 0. So x times e to the power of x times 2 minus x in brackets equals 0. And using the null factor law, x equals 0 makes this entire expression equal to 0, and also x equaling 2 makes this entire expression also equal to 0. E to the power of x itself cannot equal 0. It's a value that's greater than 0 for all real values of x. So this expression here equaling 0 only depends on this term here, this x term, and this 2 minus x here in brackets. So we get x equals 0 or 2. So we have two stationary points at those values of x. Now the question is asking us to find the stationary points, which means we need the y coordinates that correspond with x equals 0 and x equals 2. So using the original function, f of x equals x squared over e to the power of x, we substitute x equals 0 and x equals 2, and we get f of 0 is equal to 0 and f of 2 is equal to 4 over e squared, which is approximately 0.54 as a decimal. The next thing we need to do is to determine the nature of the stationary points. So they're either local minimums, local maximums, or they could be horizontal points of inflection. And we can use a table of gradients to determine the nature of these stationary points. Or we could use the second derivative, but I think a table of gradients, so using the first derivative in this instance, would be simpler. Now we know that a stationary point exists at x equals 0 and also at x equals 2. So I'm going to pick points around x equals 0 and x equals 2. So I've picked x equals -1, x equals 1, and x equals 3. And I'm going to determine the value of the first derivative at those other values of x. So when x equals -1, using the first derivative expression here, so substituting x equals -1, we get approximately -8. So that's represented with a downward arrow, so it's a negative gradient. Now at x equals 0, that's a stationary point, so it's represented with a horizontal arrow. When x is equal to 1, the value of f dash of x is around 0.4, that's a positive. So I've represented that with a upward arrow there, so just on an uphill. When x is equal to 2, f dash of x is equal to 0, so that's a horizontal arrow here. And when x is equal to 3, f dash of x is equal to approximately -0.1. So that's represented with a downward arrow from left to right. So from that table of gradients, we can conclude that the stationary point at 0, 0 is a local minimum, and the stationary point at 2, 4 over e squared is a local maximum. Part B. A partially completed graph of f of x equals x squared over e to the power of x is shown. Use your answer from part A to complete the graph. From part A, we know that there is a local minimum at the origin, so at 0, 0, and there is a local maximum at 2, 4 over e squared, which is around 0.54 or 0.5. Notice that we have 0.5 here on the y-axis. Now, to make the graphing a little bit more accurate, one technique we could use is to put a ruler here, so line it up with the x-axis, like so, and then use a set square, like this. So line it up roughly where x equals 2, and we're going to draw a faint, just a vertical guideline there, like that. And then I'm going to repeat the same thing, but I'm going to draw a horizontal guideline at y equals 0.5, which is close to 0.54, so like that. And you can see that I've located the point where the local maximum occurs. I'm just going to put an X there. And I'm going to put an X here as well. That's for our local minimum. Now to sketch the curve. So just carefully, I'm just going to just lightly sketch it in. Right. Just as long as it's rough, but close. So up to here, so that's our local maximum. And then we'll curve it down to this part of the curve there. Now I'm going to darken it. Like so. For completeness, it's good practice to write the coordinates of the stationary points that we found. So this point here from part A was 2, 4 over e squared. And this point here is already at the origin, so I don't need to label that. Question 17. A borrower obtains a reducing balance loan of $800,000 to buy a house. Interest is charged at 0.5% monthly, compounded monthly. On the last day of each month, interest is added to the balance owing on the loan, and then the monthly repayment of $5,740 is made. Let A dollars be the balance owing on the loan at the end of n months. Part A. Show that A2 equals 800,000 times 1.005 squared minus 5,740 times 1.005 minus 5,740. Let's work out the balance owing at the end of the first month. In other words, work out A1. So A1 is equal to 800,000, so that's the principal. We're going to increase that by 0.5%. That's the interest that the bank adds. So that's 800,000 times 1.005. But then we're going to take away the monthly repayment of 5,740. So I'm not going to evaluate this. I'm just going to leave it in this form. Now let's work out A2, which is the balance owing at the end of the second month. So we take what is owing at the end of the first month. The bank will add 0.5% interest, and we do that by multiplying A1 by 1.005. And then we take away the second monthly repayment of 5,740. But we have an expression for A1. A1 is 800,000 times 1.005 minus 5,740. So in place of A1, I'm going to write the expression for A1. So we have A2 is equal to 800,000 times 1.005 minus 5,740. So I've placed that inside brackets there and there. And we're going to multiply that by 1.005. So that comes from this bracket here. And we're going to take away 5,740, which comes from here. So taking this term inside the brackets, we're going to multiply that by 1.005 and we get 800,000 times 1.005 squared. Then we're going to take 5,740 and we're going to multiply that by 1.005 and we're going to take that away from this term here. So we have minus 5,740 times 1.005 and then we take away 5,740, which is our expression for A2 as required. Part B. Show that AN equals 1,148,000 minus 348,000 times 1.005 to the power of n. Using the result from part A, we can generalize an expression for AN. So going back to part A, we can see that A2 is equal to 800,000 times 1.005 to the power of 2. So notice that this index here matches the value of the subscript here. So if this was A3, this one here would be 3. If this was A10, this one here will be 10 as well. If this was AN, this one here will be N as well. Then we subtract from that 5,740 times 1.005 to the power of 1. So that's 1 less than 2. And then we take away 5,740. So if this was A3, it would be A3 equals 800,000 times 1.005 to the power of 3 minus 5,740 times 1.005 to the power of 2 minus 5,740 times 1.005 minus 5,740. Now, I did not show the expression for A3, but we have enough here that we can generalize an expression for AN. So we have AN is equal to 800,000 times 1.005 to the power of n minus 5,740 times 1.005 to the power of n minus 1, so that's 1 less than n, minus 5,740 times 1.005 to the power of n minus 2, so we're going down by 1 each time, minus minus 5,740. And that's where the expression ends. Notice the second term in the expression all the way to the last term. We can factorize out 5,740. Actually, more precisely, we can factorize out negative 5,740. And we get AN is equal to 800,000 times 1.005 to the power of n minus 5,740, open bracket, 1 plus 1.005 plus 1.005 squared plus plus 1.005 to the power of n minus 1, close brackets. Notice what we have in the brackets here after the negative 5,740. We have a geometric series with n terms. The common ratio is 1.005 and the first term is 1. Because we have a geometric series here, and we know what the first term is, we know what the common ratio is, we know that there are n terms, we can represent this entire series with the sum of a geometric series formula. So AN is equal to 800,000 times 1.005 to the power of n minus 5,740. Now we open bracket, 1 minus 1.005 to the power of n, so that's our 1 minus r to the power of n over 1 minus r, so that's 1 minus 1.005. Now we can simplify the expression for AN. So we can divide negative 5,740 by 1 minus 1.005, and we get positive 1,148,000. So AN is equal to 800,000 times 1.005 to the power of n plus 1,148,000 times, open bracket, 1 minus 1.005 to the power of n, close bracket. Now we can expand the bracket here by multiplying through by 1,148,000, and we get AN is equal to 800,000 times 1.005 to the power of n plus 1,148,000 minus 1,148,000 times 1.005 to the power of n. Now we have two like terms, so this term here and this term here. So we have 800,000 times 1.005 to the power of n, and we can combine that with negative 1,148,000 times 1.005 to the power of n, and we get AN is equal to 1,148,000 minus 348,000 times 1.005 to the power of n as required. Part C. After how many months will the balance owing on the loan first be less than $400,000? We need to find the value of n. Now recall that n represents the number of months since the loan was taken out, such that the value of AN is equal to $400,000. And it's beyond that value of n, and n is an integer, where the balance owing will be less than 400,000. Now, because n is an index, we will need to use a logarithm to find this value of n, and we'll do that later on. So we want to solve AN equals 400,000. Now, from part B, we have an expression for AN, and we have 1,148,000 minus 348,000 times 1.005 to the power of n is equal to 400,000. Now, subtracting 1,148,000 from both sides of the equation, we get negative 348,000 times 1.005 to the power of n is equal to negative 748,000. So isolating 1.005 to the power of n, in other words, making it the subject of the equation, we get 1.005 to the power of n is equal to negative 748,000 divided by negative 348,000. And that simplifies to 187 divided by 87, or as a fraction, 187 over 87. I'm just going to leave it in this form here. I'll do all the rounding at the very end. So now we need to isolate n, and we do that by taking the logarithm of both sides of the equation. Now you can use whatever logarithm you like. I'm going to use log base 10. As long as it's log base 10 on both sides, it'll be fine. Or we can use the natural logarithm. So log base 10 of 1.005 to the power of n is equal to log base 10 of 187 divided by 87. So n comes out to the front here, and we can divide both sides of the equation by log base 10 of 1.005. So n is equal to log base 10 of 187 divided by 87, and we divide that by log base 10 of 1.005. And we can evaluate the right-hand side, and we get n is equal to 153.422 and so on months. So it's greater than 153. So we have to round up, because in the 153rd month, the balance owing will be slightly more than $400,000. So therefore, the balance owing will be less than $400,000 after 154 months. Question 18. Find the range of g of f of x given f of x equals 3 over x minus 1 and g of x equals x plus 5. Consider the composite function or the composition g of f of x. Now g is the outer function, g of x equals x plus 5, and f of x is the inner function, f of x equals 3 over x minus 1. So composing g of f of x, starting with g of x, we replace x here and here with f of x to get our g of f of x. So x is replaced with the definition of f of x, which is 3 over x minus 1. So in other words, where you see the x, replace it with 3 over x minus 1. So g of f of x is equal to 3 over x minus 1 plus 5. Let's look at the property of 3 over x minus 1. Now that's a hyperbola. It's been shifted to the right by 1 unit. That's what the minus 1 does. That shifts the vertical asymptote from the y-axis to the line x equals 1. Now the 3 just dilates or stretches the hyperbola vertically by a factor of 3. Now the question's asking for the range, not for the domain. So the minus 1 here has no effect on the range, nor the 3 for that matter. So the hyperbola 3 over x minus 1 has vertical asymptote at x equals 1 and a horizontal asymptote. Now that's what we're interested in. The horizontal asymptote is the x-axis. So that's at x equals 0. That means the range of 3 over x minus 1 is all real values of y, but y cannot equal 0. Then we add 5. Now what does the plus 5 do? That shifts the hyperbola 3 over x minus 1 upwards by 5 units. That means the horizontal asymptote has also moved upward by 5 units. So rather than the range being all real y, but y cannot equal 0, the range becomes all real values of y, but y cannot equal 5. And I've stated that here. So the graph of g of f of x is a hyperbola with a horizontal asymptote at y equals 5. Therefore, the range of the composition g of f of x is all real values of y, where y cannot equal 5. Or in interval notation, open round bracket, minus or negative infinity, comma 5, close round bracket, union, open round bracket, 5, comma infinity, close round bracket. Question 19. 3 girls, Amara, Bala and Cassie, have nominated themselves for the local soccer team. Exactly one of the girls will be selected. The chances of their selection are in the ratio 1 to 2 to 3 respectively. The probability that the team wins when Amara is selected is 0.5, when Bala is selected is 0.4, and when Cassie is selected is 0.2. Given that the team wins, find the probability that Amara was selected. This problem is an instance of conditional probability, and we want the probability that Amara is selected given that the team wins. And that's given by the expression, the probability that Amara is selected and the team wins. So the operative word here is and we divide that by the probability that the team wins regardless of who was selected. So the probability that Amara is selected and the team wins is 1 over 6 times 0.5. Now the 1 over 6, that's the probability that Amara is selected, comes from this ratio here. If we add the terms of the ratio together, 1 plus 2 plus 3 is equal to 6, and the first term of the ratio corresponds to Amara. So that's why it's 1 over 6 here. And then we multiply that by the probability that the team wins when Amara is selected. And then we divide that by the probability that the team wins regardless of who is selected. So we divide that by 1 over 6 times 0.5. So that's the probability that the team wins and Amara is selected, plus 2 over 6 times 0.4. So that's the probability that the team wins when Bala is selected, plus 3 over 6 times 0.2. And that's the probability that Cassie is selected and the team wins. So we close the bracket there and we evaluate that expression and we get 5 over 19. Therefore, given that the team wins, the probability that Amara was chosen is 5 over 19, which is around 26%. We can also solve this graphically by drawing a tree diagram. Now, in the first stage, we show the probabilities of either Amara, Bala, or Cassie are chosen. So Amara getting chosen, probability is 1 over 6. The probability for Bala being chosen is 2 over 6, and the probability for Cassie being chosen is 3 over 6. Now, in the second stage, we show the probability that the team either wins or loses. So if Amara is chosen, the probability of a win is 0.5. If Bala is chosen, the probability of a win is 0.4. And if Cassie is chosen, the probability of a win is 0.2. So the probability that Amara was chosen, given that the team wins, is equal to the probability that Amara was chosen and the team wins. So that's Amara and win. So this branch here times this branch here. So 1 over 6 times 0.5 is 1 over 12. And that's why we have a 1 over 12 here. And we divide that by the probability that the team wins regardless of who was chosen. So we add these three probabilities together. 1 over 12, 2 over 15, which we get by multiplying 2 over 6 times 0.4, and 1 over 10, which we get by multiplying 3 over 6 times 0.2. So the probability that Amara was chosen, given that the team wins, is equal to 1 over 12 divided by, open bracket, 1 over 12 plus 2 over 15 plus 1 over 10, close bracket, and that evaluates to 5 over 19. Question 20. The table shows future value interest factors for an annuity of $1. Lynn invests a lump sum of $21,000 for 7 years at an interest rate of 6% per annum, compounding monthly. Yemi wants to achieve the same future value as Lynn by using an annuity. Yemi plans to deposit a fixed amount into an investment account at the end of each month for 7 years. The investment account pays 6% per annum, compounding monthly. Using the table provided, determine how much Yemi needs to deposit each month. We'll start by working out the future value of Lynn's investment. Now, Lynn invests a lump sum of $21,000 at 6% per annum, compounded monthly, for a period of 7 years. So using the compound interest formula, or the future value formula, that is, future value is equal to the present value, or the principal, times 1 plus r in brackets to the power of n. Now the r is 0.06 divided by 12. Now 0.06 is 6% as a decimal, and we divide that by 12 because it's 6% per annum or per year, but it's compounded monthly, and there are 12 months in a year. So the compound interest rate per month is 0.06 divided by 12. But we need to raise that to the power of the total number of compounding periods over 7 years. There are 12 compounding periods per year, and we multiply that by 7, and that gives us 84. So evaluating this expression, 21,000 times 1 plus 0.06 divided by 12 in brackets to the power of 7 times 12, or to the power of 84, we get $31,927.76 correct to the nearest cent. Now let's consider Yemi's investment. We know the future value of Yemi's investment must equal the future value of Lynn's investment, which is $31,927.76. But rather than investing all that money up front as a lump sum, Yemi will be using an annuity. So there'll be a monthly deposit, and we need to work out what the value of that monthly deposit is so that the future value of Yemi's investment is equal to this value here. So we need to find the correct interest factor from the table. So we need to find out the value of R, which is the rate of compound interest per period. Now we know it's 0.06, so that's 6% per annum. Dividing that by 12, and we get R is equal to 0.005. So that gives us which column to select from the table. But in order to work out which row, we need to work out the total number of compounding periods. Now we've already worked that out. That's 7 times 12, and that gives us 84. So going back to the table, we select the column with the heading of 0.005 and the row which has a heading of 84, and where the column and the row intersect, this is our interest factor. So the interest factor is 104.07393. So to work out the future value, we take the monthly deposit and we multiply that by the interest factor. Now we know what the future value is. It's $31,927.76. And that's equal to the monthly deposit multiplied by the interest factor that we just found. So we form a simple equation, and we need to make the monthly deposit the subject. And we do that by dividing 31,927.76 by 104.07393. And I've written that equation here, rearranged so that the monthly deposit is the subject. And that evaluates to $306.78. Question 21. A continuous random variable x has a probability density function given by f of x equals 0 for x less than 1, f of x equals 1 over x for x greater than or equal to 1 and less than or equal to e, and f of x equals 0 for x greater than e. Part A. Find the mode of the given probability density function. Justify your answer. The mode of a probability density function is the value of x, or the score, that corresponds to the maximum value of f of x. Now it helps to sketch the graph of f of x equals 1 over x in the interval x greater than or equal to 1 and less than or equal to e. And we want to find where f of x is maximum, and then the value of x that corresponds to that maximum is the mode. So graphing f of x equals 1 over x, we have a hyperbola. Now this is the point where x equals 1, and this is the point where x equals e. Now when x equals 1, the value of the function is 1, and when x is equal to e, the value of the function is 1 over e, which is less than 1. So we can see from the graph that f of x is maximum when x is equal to 1. And I've stated that here. In the interval where x is greater than or equal to 1 and less than or equal to e, the maximum value of f of x equals 1 over x occurs when x equals 1. Therefore, the mode is 1. Part B. Calculate the value of the 25th percentile, Q1, of this distribution. Give your answer correct to 3 decimal places. We want to solve for the variable t the integral equation. The integral of 1 over x dx equals 0.25 from x equals 1 to x equals t. So integrating 1 over x with respect to x, we get ln of x, and the bounds of integration are from x equals 1 to x equals t, and the value of this integral is 0.25. Applying the limits of integration, we get ln of t minus ln of 1 is equal to 0.25, and we want to solve for t. Now note that ln of 1 is equal to 0. So the equation simplifies to ln of t is equal to 0.25. Raising both sides of the equation to the base e to cancel out this ln function, we get t is equal to e to the power of 0.25, which is approximately 1.284025 and so on. But we need to round that value correct to 3 decimal places. Therefore, the first quartile, Q1, is equal to 1.284, correct to 3 decimal places. Question 22. Prove that sine to the power of 4 theta plus cos to the power of 4 theta over sine squared theta cos squared theta plus 2 equals sec squared theta cosec squared theta. We'll start by considering the expression on the left-hand side of the identity. So the left-hand side is equal to sine to the power of 4 theta plus cos to the power of 4 theta over sine squared theta times cos squared theta plus 2. So we'll combine the 2 and the fraction together into a single fraction by finding a common denominator. And we do that by multiplying the 2 by sine squared theta cos squared theta, and then we'll divide that by sine squared theta cos squared theta to compensate. So we end up with the left-hand side equaling sine to the power of 4 theta plus cos to the power of 4 theta plus 2 sine squared theta cos squared theta over sine squared theta cos squared theta. Now I'm going to rearrange the numerator just to make it more apparent as to what I'm about to do later on. So rearranging the terms of the numerator, we get cos to the power of 4 theta plus 2 times sine squared theta cos squared theta plus sine to the power of 4 theta over sine squared theta cos squared theta. Now in the numerator, we have a perfect square which can be factorized. And that can be factorized as cos squared theta plus sine squared theta in brackets to the power of 2. And that's over sine squared theta cos squared theta. Now recall the Pythagorean trigonometric identity, cos squared theta plus sine squared theta is equal to 1. So the numerator becomes 1 squared, which is equal to 1. And I've written that here. And that's over sine squared theta cos squared theta. And that's equal to 1 over sine squared theta times 1 over cos squared theta. Now these are reciprocal trigonometric ratios. 1 over sine squared theta is cosec squared theta, and 1 over cos squared theta is sec squared theta. So 1 over sine squared theta cos squared theta is equal to sec squared theta cosec squared theta, which equals the right-hand side as required. Question 23, Part A. In a flock of 12,600 sheep, the ratio of males to females is 1 to 20. The weights of the male sheep are normally distributed with a mean of 76.2 kilograms and a standard deviation of 6.8 kilograms. In the flock, 15 of the male sheep each weigh more than X kilograms. Find the value of x. The first thing we need to find is the number of male sheep. Now it's given that there are 12,600 sheep in the flock and the ratio of males to females is 1 to 20. So to find the number of male sheep, we take the total number of sheep and we divide that by the sum of the terms of the ratio. So 1 plus 20 is 21, and that gives us the value of one part, and then we multiply it by the value of the first term of the ratio, which is 1, and that gives us the number of male sheep. So 12,600 divided by 21 times 1 is equal to 600. Now, out of those 600 male sheep, 15 of those male sheep each weigh more than X kilograms. So as a percentage, 15 divided by 600 times 100 is equal to 2.5%. So the top 2.5% of the male sheep each weigh more than X kilograms. Now, because they are normally distributed, we can use the empirical rule, also known as the 68, 95, 99.7 rule, to work out the value of X. The top 2.5% corresponds to 2 standard deviations above the mean. So looking at the normal distribution, this is the top 2.5% there. And that occurs above Z equals 2. So to work out the value of X, we take the mean, which is 76.2, and then we add on to that 2 lots of the standard deviation of 6.8. So X equals 76.2 plus 2 times 6.8, which gives us 89.8. Part B. The weights of the female sheep are also normally distributed but have a smaller mean and a smaller standard deviation than the weights of the male sheep. Explain whether it could be expected that 300 of the females from the flock each weigh more than X kilograms, where X is the value found in Part A. We worked out in Part A that there are 600 male sheep. Now, if there are 12,600 sheep in total, that means there are 12,000 female sheep. Now, out of those 12,000 female sheep, the question is, explain whether it could be expected that 300 out of the 12,000 female sheep from the flock each weigh more than X kilograms. So as a percentage, 300 divided by 12,000 times 100 is equal to 2.5%. And just like in Part A, 2.5% corresponds to a Z-score of 2. Now, since the mean mu is less than 76.2 kilograms and the standard deviation sigma is less than 6.8 kilograms, a Z-score of 2 for the female sheep would correspond to an actual weight that is less than 89.8 kilograms. Hence, less than 300 female sheep would weigh more than X kilograms. Question 24. The graphs of y equals e times ln x and y equals ax squared plus c are shown. The line y equals x is a tangent to both graphs at their point of intersection. Find the values of a and c. Define point P with coordinates x, y as the common point of contact between the tangent y equals x and the graphs of y equals ax squared plus c and y equals e times ln x. So the overall strategy is to find the coordinates of point P, so in other words, finding the values of x and y, and we use this graph here, y equals e times ln x, to do that. And once we have that, we can proceed to find the values of A and C on the graph of y equals ax squared plus c. Now, since point P is a common point of contact of the tangent to both graphs, the gradient of the tangent to both curves is identical. So looking at y equals x, clearly the gradient is equal to 1. So if we differentiate y equals e times ln x, at the point P, the value of the derivative is equal to 1. So the derivative of e times ln x, noting that e is a multiplying constant, that's equal to 1 at the point P, x comma y. So differentiating e times ln x, we get e over x, and that's equal to 1. So solving this equation, we get x is equal to e. And because point P lies on the line y equals x, whatever x is, y is equal to that value. So if x is equal to e, that means y is also equal to e. So point P has coordinates e, comma e. This also implies that the graph of y equals ax squared plus c passes through the point e, comma e. Now to differentiate ax squared plus c. Now at the point P, the value of that derivative is also equal to 1. So in other words, at the point where x equals e. So differentiating ax squared plus c, we get 2 times a times x is equal to 1. Noting that x is equal to e, so substituting e for x here, and then solving this equation for a, we get a is equal to 1 over 2e. Now I've made the point earlier that the point P with coordinates e, comma e lies on the graph of y equals ax squared plus c. And we just found the value of a, which is 1 over 2e. So substituting 1 over 2e for a here, and e for x and e for y, we can then solve for c. So e is equal to 1 over 2e times e squared plus c. And that's e equals e squared over 2e plus c. So we can do some cancellation here. So we get e is equal to e over 2 plus c. And solving for c, we get c is equal to e over 2. Therefore, a equals 1 over 2e and c equals e over 2. Question 25, Part A. Show that d dx of sine x minus x cos x equals x sine x. Since we are finding the derivative of the difference between two terms, we can differentiate the individual terms and then subtract one derivative from the other. In other words, the derivative of the difference is equivalent to the difference of the derivatives. Let's consider the derivative of the first term, sine x. So d dx of sine x is equal to cos x, and we'll call this expression number 1. And d dx of x cos x, and because we have a product of two functions in x, we need to use the product rule, and we get 1 times cos x plus x times negative sine x, which simplifies to cos x minus x sine x, and we'll call this expression number 2. So from numbers 1 and 2, so expression number 1 minus expression number 2, we get d dx of sine x minus x cos x is equal to cos x minus, open bracket, cos x minus x sine x, close bracket. Now when we expand the brackets, the cos x cancels with this cos x here, so it's cos x minus cos x, and it's going to be plus x sine x because we have a double negative here and here, and that gives us x sine x as required. Part B. Hence, find the value of the integral of x sine x dx from x equals 0 to x equals 2025 pi. From part A, we found that the derivative of sine x minus x cos x is x sine x. Reversing that, the integral or the primitive of x sine x dx is equal to sine x minus x cos x plus the constant of integration c. But we're finding a definite integral, not an indefinite integral, so we don't need the constant c. So the integral of x sine x dx from x equals 0 to x equals 2025 pi is equal to sine x minus x cos x from x equals 0 to x equals 2025 pi. Applying the limits of integration, we get sine 2025 pi minus 2025 pi times cos of 2025 pi minus 0. We get the 0 when we substitute 0 here and here. This expression equals 0. So we only need to worry about this expression here. Now we can enter this directly into your calculator. Make sure that the calculator is set to radian mode. And we get 0 minus 2025 pi times negative 1, and that equals 2025 pi. Part C. The regions bounded by the x-axis and the graph of y equals x sine x for x greater than or equal to 0 are shown. Let an equal the integral of x sine x dx from x equals n minus 1 times pi to x equals n pi, where n is a positive integer. It can be shown that the absolute value of an is equal to 2n minus 1 times pi. Do not prove this. Find the exact total area of the regions bounded by the curve y equals x sine x and the x-axis between x equals 0 and x equals 2025 pi. The total exact area is given by A1 plus A2 plus A3 plus A4 and so on up to A of 2025. Now these areas are considered unsigned areas, and that's using the fact given. In other words, the absolute value of an is equal to 2n minus 1 in brackets times pi. And we'll need to use that fact in order to find the exact area from x equals 0 to x equals 2025 pi. So the exact area equals A1 plus A2 plus A3 plus dot 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 plus A of 2025. And using the given fact, that equals pi plus 3 pi plus 5 pi plus dot 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 plus 4049 pi. And we can factorize out pi. So we get exact area is equal to pi times open bracket 1 plus 3 plus 5 plus dot 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 plus 4049 close bracket. And we'll call this equation number 1. Now if we consider what's inside the brackets, 1 plus 3 plus 5 plus dot 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 plus 4049, we have an arithmetic series with the first term a equals 1. We have a common difference of 2. The total number of terms is 2025. And that makes sense because we're considering A1 plus A2 plus A3 right up to A of 2025. And the last term is 4049. So there's one of two formulas we can use to find the sum of an arithmetic series. And because we have A, we have N, and we have L, we can use the N over 2 times A plus L in brackets formula to find the sum of this series. So from equation number 1, the exact area is equal to pi times 2025 over 2 times open bracket 1 plus 4049 close bracket. So evaluating what's inside the square brackets, we get pi times open square bracket 2025 times 2025 close square brackets. Now you may be wondering about this. 1 plus 4049 is 4050. Dividing that by 2, we get 2025. So 2025 times 2025 is 2025 squared. So the exact area is equal to 2025 squared times pi square units. Question 26. A piece of wire is 100 centimeters long. Some of the wire is to be used to make a circle of radius r centimeters. The remainder of the wire is to be used to make an equilateral triangle of side length x centimeters. Part A. Show that the combined area of the circle and equilateral triangle is given by a of x equals 1 over 4 times open bracket root 3 times x squared plus 100 minus 3x in bracket squared over pi close bracket. Let's consider the equilateral triangle first. Now we're told that the side length is x centimeters. Now given that it's equilateral, all sides are equal in length. So the perimeter of the equilateral triangle is 3 times x or 3x. Now if the length of wire is 100 centimeters and 3x centimeters is used to make the equilateral triangle, the remaining wire is then bent around to form a circle. So the circumference of the circle is 100 minus 3x centimeters, and we'll consider that later on. So let's find the area of the equilateral triangle. Now if we divide an equilateral triangle straight down the middle, so this dashed line here, this represents the vertical height or the perpendicular height of the triangle. We can use Pythagoras' theorem to find the height. We have a hypotenuse of x centimeters, and the base of the right angled triangle is x over 2. So the height of the triangle using Pythagoras' theorem is the square root of x squared minus x over 2 in brackets squared. So that's the hypotenuse squared minus the short side squared, and we take the square root of that. And we get square root of 3x squared over 4, and we can simplify that further. The denominator of 4 can be taken outside of the square root, and we also have x squared inside the square root, which can also be taken outside. So we get height is equal to half times root 3 times x. So to find the area of the triangle, we use the formula half times base times perpendicular height. Now the base of the triangle is x, and we know the height. So half times x times half times root 3 times x gives us 1 over 4 times root 3 times x squared. And we'll call this expression number 1. Now let's consider the circle. We know that the circumference of the circle is 100 minus 3x centimeters, but we want the radius of the circle in order to work out its area. And we know that the circumference of a circle is given by the formula circumference equals 2 pi r. So 100 minus 3x is equal to 2 pi r. And we can rearrange that equation to make r the subject. And we get r is equal to 100 minus 3x over 2 pi. So to find the area of the circle, we use the formula area equals pi r squared. So we have pi times radius squared, so that's 100 minus 3x over 2 pi, all in brackets, squared. Now the 2 pi in the denominator, if we take it outside of the brackets, becomes 4 pi squared. And there'll be some cancellation here, so the pi will cancel with the pi here, so the pi squared in the denominator will cancel with the pi outside of the brackets. So we end up with this expression here. So the area of the circle is 1 over 4 times 100 minus 3x in brackets squared over pi. So notice that the pi is not inside the brackets. And we'll call this expression number 2. So to find the total area, we take this expression here, number 1, we add it to expression number 2. So we have 1 over 4 times root 3 times x squared plus 1 over 4 times 100 minus 3x in brackets squared over pi. Notice that we have a common factor of 1 over 4, which can be factorized out. And we get 1 over 4 times open bracket root 3 times x squared plus 100 minus 3x in brackets squared over pi, close brackets, as required. Part B. By considering the quadratic function in Part A, show that the maximum value of a of x occurs when all the wire is used for the circle. Let's consider the coefficient of the x squared term in the expression for a of x. So going back to the expression in part A, we have a of x is equal to 1 over 4 times this quadratic expression in the large set of brackets. And the coefficient for x squared determines the direction of the resulting parabola when it's graphed. So if the coefficient of x squared is positive, it'll be a concave up parabola, which means the vertex represents a minimum point. And if the coefficient is negative, then it's a concave down parabola. So the vertex represents a maximum point. So considering the coefficient of x squared in the expression for a of x, now we have root 3 times x squared. Now clearly root 3 is positive. And the other coefficient of x squared occurs, actually I'll go back to the expression for a of x. It occurs here. So we have 100 minus 3x in brackets squared. Now if you expand this, we have negative 3x times negative 3x, which gives us a term involving x squared. So we have root 3 times x squared plus negative 3x in brackets squared gives us 9 plus root 3 in brackets times x squared. And we can see that the coefficient is positive, which implies that the graph of a of x is a concave up parabola, which further implies that the stationary point, or the vertex, is the minimum. Therefore, the maximum value of a of x will occur at an endpoint of the domain. In other words, either when r is equal to 0, so all the wire is used for the triangle, or when x is equal to 0. So that implies a side length of the triangles equal to 0. So that means all the wire is used to form the circle. So let's consider the two cases. So in other words, the two endpoints of the domain. Find the value of a of x and obviously determine which one is larger. So when x is equal to 0, so in other words, all the wire is used for the circle, the total area, a of x, is found by substituting 0 for x in this equation here, and we evaluate that. So we get a of 0 is equal to 1 over 4 times 100 squared over pi, which gives us around 796 square centimetres. Now let's consider the case when r is equal to 0. In other words, there's no circle, all the wire is used to form the triangle. So it'll have a side length of 33 1/3 centimetres. And evaluating a of 33 1/3, we get approximately 481 square centimetres. And from these two results, we can see that a of 0 is greater than a of 33 1/3. So x equals 0 implies all the wire is used for the circle, which means that we can conclude that the maximum value of a of x occurs when all the wire is used for the circle. Question 27. The shaded region is bounded by the graph y equals half to the power of x, the coordinate axes, and x equals 2. Part A. Use two applications of the trapezoidal rule to estimate the area of the shaded region. We can use the extended trapezoidal rule to save time, noting that the value of h is 1, and we have our three function values. We have y equals 1, or y equals half to the power of 0. We have y equals half to the power of 1 in the center, and we have y equals half squared at the other end. So using the extended trapezoidal rule, we have area is approximately equal to h over 2 or 1 over 2 times open bracket half to the power of 0 or 1 plus 2 times half to the power of 1. And that's because this parallel side here is a common side between the two trapeziums, which is why it's doubled here, plus half squared, close brackets, and that evaluates to 9 over 8 square units, or as a decimal, 1.125 square units. Part B. Show that the exact area of the shaded region is 3 over 4 times ln of 2. If we were to differentiate half to the power of x being an exponential expression, the derivative of half to the power of x is just half to the power of x times ln, or the natural log of the base, so it'll be times ln of half. When we're integrating half to the power of x, we get half to the power of x, but rather than multiplying by ln of 1 over 2, we divide by ln of 1 over 2. So the integral of half to the power of x is half to the power of x divided by ln of 1 over 2, and that's from x equals 0 to x equals 2. Applying the limits of integration, noting that this division by ln of 1 over 2 can be placed outside of the brackets, we get half to the power of 2 minus half to the power of 0 in brackets divided by ln of 1 over 2. Evaluating what's in the brackets here, so half squared minus half to the power of 0 is negative 3 over 4. Also noting that ln of 1 over 2 is equivalent to negative ln of 2, using one of our logarithm laws. So we have negative 3 over 4 divided by negative ln of 2. This goes in the denominator of the fraction, and the two negatives will cancel to become a positive, and we get 3 over 4 ln of 2 square units as required. Part C. Using your answers from Part A and Part B, deduce e less than 2 root 2. Looking at the graph of y equals half to the power of x, we can see that it's concave up. This means that the trapezoidal rule will overestimate the shaded area. This also implies that the result that we obtained in Part A, in other words, the estimate of the area, which is 9 over 8, will be greater than the exact area that we found in Part B. That is 3 over 4 times ln of 2. So we can form an inequality. That is, 9 over 8 is greater than 3 over 4 ln of 2, or we can write it the other way around. 3 over 4 ln of 2 is less than 9 over 8. So let's have a look at the solution in a little more detail. So from Part A, the trapezoidal rule overestimates the area since the curve y equals half to the power of x is concave up. Hence, we can form this inequality. 3 over 4 times ln of 2, so this is the exact area, is less than the estimate, 9 over 8. And that's from parts A and B. So if we divide both sides of this inequality by 3 over 4 to isolate 1 over ln of 2, we get 1 over ln of 2 is less than 3 over 2. If we take the reciprocal of both sides of this inequality, we switch the inequality symbol around. So we get ln of 2 is greater than 2 over 3. Multiplying both sides of this inequality by 3, we get 3 times ln of 2 is greater than 2. Now 3 ln of 2 is equivalent to ln of 8. Recall that 8 is 2 to the power of 3. So this 3 comes inside the ln function and becomes an index here. So 2 to the power of 3. Now raising both sides of this inequality to base e, we get 8 is greater than e squared, which implies that e squared is less than 8. Taking the positive square root of both sides of this inequality, we get e is less than the square root of 8. And if we simplify the square root of 8, recall that 8 is 4 times 2. The 4 can come outside of the surd and becomes 2. So we get, therefore, e is less than 2 root 2 as required. Question 28. A farmer wants to use a straight fence to divide a circular paddock of radius 10 meters into two segments. The smaller segment is 1/4 of the paddock and is shaded in the diagram. The fence subtends an angle of theta radians at the center of the circle as shown. Part A. Show that theta equals sine theta plus pi over 2. We know that the area of the minor segment is 1/4 the area of the entire circle. So the area of the minor segment is equal to 1/4 times pi r squared. Now r is 10. So 1/4 times pi times 10 squared is equal to 25 pi square meters. But that's also equal to 1/2 times 10 squared times theta minus sine theta. And that comes from the area of a minor segment formula. That is 1/2 times r squared times theta minus sine theta in brackets. So what we do is to equate these two expressions. In other words, 25 pi is equal to this expression expanded out. So 25 pi equals 50 theta minus 50 times sine theta. Dividing all terms by 50, we get pi over 2 is equal to theta minus sine theta, and then rearranging the equation to make theta the subject, we get theta is equal to sine theta plus pi over 2 as required. Now one last point, going back to this equation here, we don't have to expand the brackets necessarily. What we could have done is to divide both of these terms by 50 first, and then we're just left with theta minus sine theta on one side of the equation, and then rearrange it to get theta equals sine theta plus pi over 2. Part B. The graph of y equals sine theta plus pi over 2 is shown. Use the graph and the result in part A to estimate the arc length of the smaller segment to the nearest meter. We want to solve graphically for theta, the equation theta equals sine theta plus pi over 2. Now we're already given the graph of y equals sine theta plus pi over 2. So what we need to do is to graph y equals theta and then find the point of intersection of the two graphs. So here is the graph of y equals theta, and we can see that the point of intersection occurs when theta is around 2.3 radians. And I've stated that here. So the point of intersection of the graphs of y equals theta and y equals sine theta plus pi over 2 occurs at theta roughly equal to 2.3 radians. So to find the arc length, we use the arc length formula. So arc length is equal to theta in radians multiplied by the radius of the circle. So that's 2.3 times 10, which is equal to 23. Therefore, the arc length of the smaller or minor segment is around 23 meters. Question 29. The point T is the peak of a mountain and the point O is directly below the mountain's peak. The point Y is due east of O and the angle of elevation of T from Y is 60 degrees. The point F is 4 kilometers southwest of Y. The points O, Y and F are on level ground. The angle of elevation of T from F is 45 degrees. Part A. Let the height of the mountain be h. Show that OY equals h over the square root of 3. In triangle OTY, we have a right angled triangle with the right angle at angle TOY. We have an angle here which is 60 degrees and we have h. So using regular right angle trigonometry, we have an opposite side. We want to express the adjacent side in terms of h and 60 degrees. So using the tan ratio, opposite over adjacent is equal to tan 60 degrees. And it just so happens that tan 60 degrees is an exact ratio, which is equal to the square root of 3. And it's stated here. So in triangle OTY, opposite over adjacent, so H over OY is equal to tan 60 degrees, which is equal to the square root of 3. So rearranging this equation to make H the subject, we get H is equal to OY times the square root of 3, and rearranging it one more time to make OY the subject, we divide both sides of this equation by root 3, and we get OY is equal to H over root 3 as required. Part B, hence or otherwise, find the value of H correct to 2 decimal places. In triangle OTF, OF is equal to H because in this right angled triangle, this angle here, so this angle of elevation is 45 degrees. We have an opposite side, we have an adjacent side, and we know that tan 45 degrees is equal to 1. So that's why OT equals OF, which equals H. And from part A, we saw that OY is equal to H over the square root of 3. And one other detail that's important is this angle here. In triangle OYF or OFY, this angle, OYF, is 45 degrees because we're told that point F is southwest of point Y and OY is the direction due east. So let's have a look at the solution. So in triangle OTF, OF equals H since tan 45 degrees is equal to 1. And in triangle OFY, angle OYF is equal to 45 degrees, which we just saw. And OY is equal to H over the square root of 3 from part A. And just to make the solution a little easier to understand, it helps to draw a diagram. So I've sketched triangle OYF here. So that's the surface or the level ground here. So we can just focus on this triangle. So OF is equal to H, OY is equal to H over the square root of 3, and angle OYF is 45 degrees, and we're told that FY or YF is 4 kilometers. So we can use the cosine rule to relate the 3 sides together and the angle that's given. So by the cosine rule, H squared is equal to H over root 3 in brackets squared plus 4 squared minus 2 times H over root 3 times 4 times cos 45 degrees. And cos 45 degrees is an exact ratio. It's 1 over the square root of 2. So this equation simplifies to H squared equals H squared over 3 plus 16 minus 8H over the square root of 6. So focusing on this equation here now, if we move everything over to the left-hand side, we can form a quadratic equation in H. And we get 2 over 3 times H squared plus 8 over root 6 times H minus 16 is equal to 0. So we can use the quadratic formula to find the value of H. So by the quadratic formula, we get H is equal to negative 7.9267 and so on, or H equals 3.0277 and so on. But H represents a height, so it can't be negative. So H is greater than 0. Therefore, H equals 3.03 meters, correct to 2 decimal places. Part C. Find the bearing of point O from point F, correct to the nearest degree. The strategy is to work out the bearing of F from O and then find the bearing of O from F by subtracting 180 degrees from the original bearing that we found. So if we go back to the diagram that was sketched in part B, we have the value of H. It was 3.03, which we found in part B. So again, focusing on triangle OFY, we know the length of all 3 sides, which means we can apply the cosine rule, or the sine rule for that matter, but I'm going to apply the cosine rule for angles to find this angle here. And if I add that to 90 degrees, since we know the bearing of y from O is 90 degrees, so if we get 90 degrees, add it to this angle here, we'll get the bearing of F from O. And there's an interesting relationship if we swap the points. In other words, the bearing of F from O and the bearing of O from F are 180 degrees apart. So let's look at the solution. So in triangle OFY, angle FOY is equal to inverse cos 16 minus 3.03 squared minus 3.03 squared over 3 all over negative 2 times 3.03 times 3.03 over root 3. And we get 110.7667 and so on degrees. We'll do all the rounding at the very end. Hence, the bearing of F from O is 110.7667 plus 90 degrees, which gives us 200.7667 and so on degrees. So to find the bearing of O from F, we subtract 180 degrees from this value here, and we get 20.7667 and so on degrees. Therefore, the bearing of O from F is 021 degrees true. As a side note, let's see what happens if we define 2 points, work out the bearing of one point from another, and then switch those 2 points around, so we'll see the effect on the bearing. So I've defined a point A here and a point B here. Let's define this angle theta here. So this angle theta represents the bearing of point B from point A. So A is our point of reference in this instance. Let's see what happens though to the bearing when we want the bearing of point A from point B. So starting at point B and facing north, we turn around in order to face point A. So if this angle here is theta, this angle here would also be theta because these two angles will be alternate to one another. And if we add 180 degrees to that, we'll get the bearing of point A from point B. And that's why there's a 180 degree difference between the bearings of point A and B when we switch the points of reference. Question 30. The parabola with equation y equals x minus 1 times x minus 5 is translated both horizontally to the right and vertically up by k units, where k is positive. The translated parabola passes through the point 6, 11. Find the value of k. We are told that the translated parabola passes through the point 6, 11. If we undo or reverse those translations, so starting with this point 6, 11, reversing the horizontal translation, so moving the point back to the left by k units by subtracting k from the x coordinate 6, and then move it vertically down by k units by subtracting k from the y coordinate, we know that the original parabola, y equals x minus 1 times x minus 5, must pass through the point 6 minus k, 11 minus k. And I've stated that here. The original parabola passes through the point 6 minus k, 11 minus k. So substituting 11 minus k for y here and 6 minus k for x here and here, we get 11 minus k equals, open bracket, 6 minus k minus 1, close bracket, times, open bracket, 6 minus k minus 5, close bracket. And we need to solve this equation for k. So simplifying the right-hand side, we get 11 minus k is equal to 5 minus k times 1 minus k. And expanding the brackets on the right-hand side, we get 11 minus k equals 5 minus 6k plus k squared. Now combining all the terms over to one side, we can form this quadratic equation. K squared minus 5k minus 6 equals 0. And that can be factorised as k plus 1 times k minus 6, and that equals 0. So by the null factor theorem, we get these two solutions. We get k is equal to -1 or k is equal to 6. But we're told that k is positive, so k has to be greater than 0. Therefore, k equals 6. Question 31. The equation cos px equals 1 over 2 has two solutions where x is greater than or equal to 0 and less than or equal to 2 pi, and p is greater than 0. Find all possible values of p. Consider the graph of y equals cos px, where p is a positive value. Now the effect that p has on the graph is that it horizontally dilates the graph. So in other words, it either stretches it or compresses it, squashes it up. And the horizontal dilation factor is 1 over p. So in other words, as p gets larger, the graph is compressed more and more, and vice versa. So I've sketched the graph y equals cos px for the purposes of this explanation, where p is equal to 1. So in other words, it's the graph of y equals cos x. And we're interested where the graph cuts the line y equals 1 over 2. In other words, we're solving the equation cos px equals 1 over 2. So in this particular instance, where p is equal to 1, we can see that there are exactly two solutions in the interval x greater than or equal to 0 and less than or equal to 2 pi. So the graph cuts the line y equals 1 over 2 here and here. And the x-coordinate of point A is 5 pi over 3. The x-coordinate of this point here is pi over 3. But this point here is not of any relevance. We're actually interested in this point here, point A, but also point B. Now, point B is outside of the interval. Now, if we vary the value of P, so recall that P horizontally dilates the graph. It either stretches it or compresses it. So if we were to stretch the graph, in other words, let's make P a little bit smaller than 1, A will move to the right. Now we want exactly two solutions. So we don't want point A to move beyond x equals 2 pi. Now if we make P greater than 1, what's going to happen is that points A and B, so B lies beyond x equals 2 pi at this point, points A and B, and also this point here, will move to the left. Now we want point B to get close to 2 pi, but we can't have point B landing on 2 pi because then we'll have three solutions. So we're interested at the points where point A lands here, so where the x-coordinate of point A is where x equals 2 pi here. We're also interested in the value of P where B lands here. In other words, the x-coordinate of point B is also 2 pi. So we want to find the values of P where A lands here and where B lands here. So we want to solve for P the equation cos of 2 pi P equals 1 over 2. Taking the inverse cos of both sides, we get 2 pi times P is equal to 5 pi over 3 and 7 pi over 3. Isolating P by dividing all values by 2 pi, we get P is equal to 5 over 6 and 7 over 6. So the smaller value of P, so 5 over 6 represents a graph that's been stretched, and the larger value of P, so that's 7 over 6, represents a graph that's been compressed. So going back to the graph, when P is equal to 5 over 6, point A moves to the right, the x coordinate of point A will land here. So in other words, it'll land where x equals 2 pi. And when P is equal to 7 over 6, point B here will move to the left and it will land at the point where x equals 2 pi. But we can't have point B landing on 2 pi exactly. And I've stated that here. So referring to the graph below, when P is equal to 5 over 6, point A has coordinates 2 pi, 1 over 2, and y equals cos px has exactly 2 solutions. And when P is equal to 7 over 6, point B has coordinates 2 pi, 1 over 2, and y equals cos px has 3 solutions. So P can't equal 7 over 6. Therefore, P is greater than or equal to 5 over 6 and less than 7 over 6.